Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily lead code problem, and the problem's name is sort colors. So you are given an array nums which is having some objects which are colored with red, white and blue. Okay, and you have to sort the array of objects in such a way that objects having same color are adjacent to each other. Okay, and their ordering should be red, white, and blue represented by the numbers 0, 1, and 2. Okay, so for example, this array is given to you. You have to basically sort this array into ascending order. Okay, because of this ordering in which we are asked to sort. Okay, it will result into ascending order because 0 is representing red and red is coming first, and 1 is representing white and white is coming second, and 2 is representing blue and blue is coming third. So when the numbers representing colors will be given to you in the array, you have to sort the array into ascending order. Okay, only then this order will be followed. And it is mentioned that you cannot use any library function. Okay, and before thinking of an approach, let's have a quick look at the constraints. So according to the constraints, the length of the array will be of order 300, and each number in the numbers array will be either 0, 1 or 2. Okay, and there is a follow-up question also. Can you come up with a one pass algorithm which uses only constant extra space? So we have to, we will be trying to solve it in one pass and constant extra space. So let's see how we can do that. So let's take one of these examples, or let me describe the algorithm to you. So what we will be doing is we will be having three pointers. Okay, so let's take three colors: red, then let's say the middle one is white, and the last one is blue. Okay, so the red one is will be pointing to the place where zeros are to be placed. Okay, so let's call this zero pointer. Okay, let's use its color, it the color that we have used only to write it. So zero pointer, and the blue one will be two pointer, the pointer which will indicate where to place 2 if you encounter it into the array. And the middle one, you can say, you can call it one pointer, or if you want you can call it just index. Okay, so it will be starting all the pointers, these two pointers will be starting from these two places, the last first index and the last index. Okay, so these two indices, and once we have started the traversal, we will be traversing the array from left to right position. Basically, what this zero pointer and two pointer will do is it will help us to, as when we will be traversing the array from this left to right direction, let's say the array be this 202 110. So 202 1 and 0. Okay, so when this one pointer will be pointing to the number 2, you will know that you have to somehow make this 2 at the end of the array. Okay, so when you will do here is you will swap these two values, this 2 and the value, being represented by 2 pointer. So after swapping, these two values will become 0 0 2 1 1, and then this will become 2. Okay, so your 2 pointer will move towards the center. Okay, so now your 2 pointer is pointing here. Okay, and you may ask, what about the 1 pointer? Will we be proceeding it or not? So in the case, we will be moving this 1 pointer only in three conditions towards right. The first condition being that if it is pointing to 1, okay, this type of condition. So if pointing to 1, okay, and the second condition being if one pointer is pointing to 0, or this index is pointing to, if it is pointing to number 0, okay, and it is equivalent to the 0 pointer, okay, both are at the same place. In that case, you will be just replacing 0 with 0, the same index number with itself, because it will be a condition when something like this will happen. So let's say this is 0 pointer and this is 1 pointer. Okay, these are some random values, but these two are pointing to the same value. Okay, and they are at the same index also. So what's the point of swapping the same value with the same index with the with itself? So in that case, we will increment our uh, 1 pointer, or you can say index. Okay, and the third condition being that index and 2 pointer are pointing to the same index. Okay, pointing to same index. In these three conditions, you will move this 1 pointer towards right. Otherwise, depending upon the value that you are encountering against the 1 pointer or the index is 0 or 2, you will move these 2 pointers towards the middle. Okay, and you will keep doing this, and at last you will be having a sorted array. Okay, so and one thing here to be noted is when we will be stopping this whole algorithm is when this 1 pointer or the index exceeds the 2 pointer. Okay, so when these two pointers will collide, let me use some different color. Okay, when these two pointers will collide, these two, and 2 pointer will be, let's say here, and let's say it is at the 0th index, for example, just for example, and the 1 pointer is at the first index. Okay, in this type of condition you will stop it will indicate you that the array have already become sorted, so you need not to proceed further. Okay, no need to do any swaps here. So what was the whole approach? I will summarize it again. You will be using three pointers, two pointers, one being the 0 pointer and the 2 pointer will be used to place zeros and twos in their respective places. And as we keep on placing zeros and twos in their respective places, these 2 pointers will move towards the center. Okay, so moving towards the center. And what will be the use of this one pointer, or you can say index? It will be used to sort of check what kind of value we are encountering when we are moving from left to right direction. Okay, if it's a zero value, then you will 0 pointer to place it in its correct place. If it's a 2 value, then you will use 2 pointer to place it in its correct place. Okay, and if it's a 1 value, or if either of these two conditions are satisfied, or if it's a 1 value, then you will move the 1 pointer one place ahead towards right. Okay, and this whole thing will stop when this condition holds true. 1 pointer exceeds the 2 pointer. Okay, it will indicate that the whole array is already being sorted, so no need to proceed further. Okay, now let's have a quick look at the implementation. So let me take the code to the board. So this is the code. So here what we will be doing is, first of all the pointers will be starting from 0th. Uh, uh, Not all the pointers. The 0th pointer will be starting from the leftmost index. 2 pointer will be starting from the rightmost index, and the index or the 1 pointer will be starting from the 0th index. Okay, and this is the condition when the whole process will terminate, as we discussed. And there will be three conditions. The current number, the number being represented by the index or the 1 pointer, can either be 2, 0, or it can be 1. Okay, in case it's 1, you will just increment the 1 pointer or the index. Okay, so, and what will be the other two conditions in which we will be incrementing the index? These two conditions will be that index and the 2 pointer are pointing to the same index, or the index or and the 0 pointer are pointing to the same index. Okay, these will be the two conditions. Otherwise, if the current number pointed to by the index is 2, then you will increment the index and place the 2 in its correct position with the help of 2 pointer, and move 2 pointer towards the middle of the array. Okay, and same we will be doing for in case the current number is 0, moving the 0 pointer towards the middle of the array. And this is just a simple swap function. Okay, so overall it is a single pass algorithm, and space complexity is constant since we are not using any extra space, just playing with the pointers. And it is a linear runtime algorithm. Okay, so all the conditions that we were required to implement the one pass solution are met, and this is the solution and the approach. If you are still having any doubts or any queries in general, then please feel free to ask them in the comment section. I hope this video solution or solution walkthrough added some value to your journey of honing your DSA skills. I will see you in the next video. Till then, keep solving problems and keep practicing. Thank you for watching.